For example, 1/2. 1/2. You say something?
No.
Okay, it's equivalent to say 1/2 raised to the x power, because I know very well that 2 to the minus 1 is 1/2. Okay, maybe, I don't know, they put like that to confuse you, but it's equivalent to say que es -1. Sorry, es 1/2 the base. And you need to remember that when the base of any exponential function is less than 1, the exponential is decreasing. And when the base is greater than 1, like in this case, the base is 4. In this case, the base is 4. In this case, no. In this case, the base is 1/2. When the base is less than 1, is like that. Let me try to do roughly sketch. When the base is greater than 1, is increase, is like that. Entonces, to do this, suppose by hand, no? We can use a decimal, of course. But suppose by hand, I want to do the graph of this, of the first one. Okay, the base is 1/2. Let's focus it in this problem. Point is 0,1. This is classical in any exponential. This one and this one, of course. Suppose another. The function passing through the point 0,1 is universal, regardless the base. It's not important the base passing through that point. Okay, now in this case, when the classical point is 0, 1, and -1. When it's 1, when the x is equal 1, it's 1/2 raised to the 1, que es obvio que es 1. Entonces 1/2, I suppose que here is a half. You take that segment and split like that, 1/2, 1/2. This point is the point 1, 1/2. And -1 is 1 over raised to the -1, and you know the interpretation for the negative exponent is reciprocal. The answer is 2 over 1, or just 2. On the side, put a 1. Guess what? When it's invisible. Entonces, -1, 2 is here. Bam, 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 bam. Our point is here. This point is the point -1, 2. You have 3 points. It's enough to interpretation get the exponential passing through this point, this point, this point, and also important. I know that any exponential, any have the horizontal at the line x equal y equals 0. Sorry, no x, es horizontal, así entonces y equals 0. But any exponential, this one also have the, and this is important piece of information. Horizontal asymptote. Horizontal asymptote. Okay, the second is exactly the same. Remember the famous point 0, 1, and -1. And 1, when the base is 4, is 4 to the 1 power, okay, 4. The point, the y value is a 4. 2, 3, 4. I suppose that the point is like that. This is a point 1,4. And -1, 4 raised to the -1 is 1/4, 1/4. 1/4 is you take that segment divided by 4 portion. The first one is 1/4. Here, this point is the point -1, 1/4. And we connecting this point, the universal, and another point by the curve, And this curve look like the exponential, in this case function. By the way, go faster because the base is 4, no? And that's it, end the story. Any question? Okay, in the test, I don't have idea what is the base I put in the test. I put 5, I put 1/3, I put, I don't know. But this is the mechanism. This is the procedure to do the graph by hand. Just in case, you can put in decimals if you want. Do you want to do in decimal or no? Yes or no? Do you want or no? You don't want?
Yes, Professor.
No. Sabrina is definitely no, Professor. This is super easy. I don't need decimal. I do by hand. Okay. In the test, and the first question I provide. Rudy say yes, I want. Okay, let's do it. Rudy, no, don't worry. And the first question in the test number 4, I provide the elegant rectangular coordinate system. Because I would like you're doing by hand this exponential, right? However, well, yeah, you know, see, you want, you put in decimals and you attach. So you know how in decimals we can, for example, okay, let me try to find decimals. Okay, a new page for the decimal, new. Suppose the first one. The first one is y equal. Okay, so sorry. Let me share screen for the decimals. Okay, good. Now I suppose that everyone saw the decimals page. Yes or no? Y equal parentheses 1/2. Close the parentheses. Power x. Boom. Do you see decimal or no? And we have the famous point. The famous point are 0,1 is the universal point. We have also separated by a comma. Another point is 1,5. That's the base. And the last point is separated by a comma, -1,2. And don't forget, important, extremely important, the horizontal axis of y equals 0. Always horizontal axis we use in black color dotted line, always, anytime. This is my first graph. You want to import, share the graphic, you export, and you send me back this download this image, so you consider it's good, and that's it. Okay, this is the first one. Let me enclose in one folder. I want to call question 1A, capital A. Oh, no, question 1, no, question 1. No A. Okay, so I put everything together. Okay, you're condensing, ready to do the next one. The next one is question 2. Another folder, I call question 2. And the question 2 is similar, it's exponential, but the base is 4. 4 exponent x. Exponent is AB. To any exponent. Boom. Wow. And remember the famous universal point 0,1. Put a label for the identification of the component. Comma. In that case, is 1,4. It's obvious, right? Look how fast increasing that exponential. And negative 1,1/4. There you go. This is my collection of the points for this exponential. At least 3 points. You want more? Let's do it more. Because when you raise, for example, to the second power is 16. F4 to the 16 is, but 3 points is enough. Any question, please? Any question? You have no problem? Thank you. Okay, let's come back. No, coño. Let's come back to the whiteboard. Whiteboard. Let me share screen to the whiteboard. Whiteboard now. Good. Okay, let's focus now in the word problem. It's important. This is an important part of the test. In the test, you can find 2 word problems. One problem is the exponential. Another word problem is the money, the investment, something, right? However, this the question number 3 is about the growth and the population fits the exponential function. Exponential function. Like that. Population at any time is equal 346 e to the 0.05 t. Remember, the general formula is population to any time is equal P null. P null is 346. I suppose this is the initial population, A to the KT, and K is the rate of change, is 0.05. Okay. Where T is the number of years. Wow. Is the number of years from since 1978. And the question say estimate the population in 2011. That's it. Let me try to interpretation this problem. The problem talking about exponential. This is exponential. This mathematical law is exponential. Now we have a problem in which this axis is the time. By the way, in that problem, the time is expressed in years. And here in this axis is a population. Capital P, population que represent, I don't know, human being or bacteria or population or something. No, not necessarily human being. And the T equals 0, que es here. T equals 0 is, in my problem, 1978. In this moment, I have 346 something, habitant. Okay, I don't know. And this law very exponential like that. I need to investigate what's going on, what happened here in one specific year, case 2011, no? This is the time expressed in 10 years, and this is the thing I want to find. How many? Estimated population 2011. Okay, Entonces, first of all, I need to find the directions, how long this time is only subtraction 2011 minus 1978, no? 33 years. Actually, the duration for this process is 33 years. Okay, and use substitution at T here, so population at 33 years is equal 346 times E to the 0.05 multiplication by 33 is the time. Okay, be careful, this is exponent. The classical mistake when the student, now you put in a calculator, of course. When you put in a calculator, you put 346 times exponential, and inside the parenthesis you put 0.05 times 33 and close the parenthesis and press enter. And you get the answer. Come on, let's do it. This is part of the review. Come on, everyone working. 346 times exponential, remember, is the same key of the natural logarithm, que es LM, but you press second and you press that key. Exactly. Yes. Let me see. Let me finish. It's a 1,801. 0.05 times 33. Close the parenthesis, press enter. Bam. Exactly. The answer is 1,801.61502. Depending on the calculator, how many decimal place. Suppose that we are talking about human being. You round. So actually, you round like a 1,802, or I don't know, or you trunk it, and you negligible that part. So either way, I accept any answer, right? Or you round to get more accurate approximation, or you trunk it because you believe the decimal of the human being or the population or whatever is not considered in the problem, depending. So this answer is acceptable, or this answer is acceptable. Okay? Any question, guys? Any question? Come on. This is a review. In the test, no. Okay. In the test, I cannot help. In the review, yes, I can help. Good. No question, no problem. Let's move on to the number 4 problem. Word problem. Okay, thank you. Number 4 word problem is, well, you suppose that you have $15,000 in investment. Which does yields the greater return. Now we have two conditions. We need to compare what is the best option. Greater return. Okay. At 10 years. Okay. Entonces we have two conditions. Number one condition, A condition is compound. Compound. Continuously at the rate, interest rate, 9.5%. And the second condition is compounded ED semi-annually, annually, MM, annually, okay, semi-annually, AMM annually interest rate 9.2. This is similar. Okay, so we have the problem, two problems actually. I need to compare. And the first problem, the present value is 15,000. And the second option is the same. It's the same investment. I need to compare two conditions. But in the first, the time is similar, 10 years. 10 years. 10 years. Okay, and the thing that change is the compounding. In this case, continuously at the interest rate 9.5%. And when you're talking about continuously, the formula is different. Because continuous, the supposition is que es exponential, continuous, no stairs. So the money no increasing step by step, sino increasing continuous at any time. And the formula is future value is equal present value exponential RT. This is the formula. I have everything in my hand. I have R, I have T, I have P. Compute that. Let's do it after. Another option is different because it's compounded semi-annually, and semi-annually is discrete. Okay, the idea is, look, continuous is something like that. This is my money, 15,000, and exponential continuous in this case. And it's not in this exponential increasing, pero like stairs. And the semi-annually, and semi-annually means que N is 2. That means these two indicate that our money increasing 2 times in 1 year. Actually, we have 10 years. So we have 10 years, so it's 20 times throughout the period. Okay? And the formula is different. Future value is equal present value 1 plus R over N raised to the NT. Okay, let's do it one by one. And the first one is A is equal 15,000 exponential. In the exponent, I put the interest rate. Be careful. Never use percent. This is wrong. You need to change to decimal. To change to decimal, you move the decimal point 2 places to the left, because actually you are divided by 100, no? So it's 0.095 times 10. This is my first calculation. Let's do it. Again, in the calculator, this is similar to the other problem because it's the same idea. You put 15,000, this display time, the famous function exponential, and the argument you put 0.095 times 10. And close the parenthesis and press enter. Okay, everyone help me. This is border. Help me. 15,000. Don't forget 30 times exponential. 0.095 times 10. Close the parenthesis, press enter. I get the answer. I'm waiting for you. The money is money. Come on, guys, working. What's going on? You have no calculator? Very well, Sabrina. It's 38,000. 785 and 64 cents. So you trunk it around to the two decimal places. And the other case, future value is equal 15,000. 1 plus interest rate in that case is, sorry, I forgot to write. Interest rate is 0.092, no? So interest rate is 0.092 divided by 2 and raise everything to the 20. We come from this 20 is the multiplication n is 2 and the time is 10, 20. This is the exponential part. How you put in a calculator? You put in a calculator like that. 15,000 time, of course, open the parentheses, 1 plus 0.092 divided by 2, close the parentheses, power 20. This is different because this is the exponential using the Euler constant, the E. However, this is the classical exponential using only power 20. Okay, you put in a calculator. Come on, everyone. No Sabrina only. Come on, guys. Another participation. 15,000 multiplication parentheses 1 plus 0.092 divided by 2. Close the parentheses. Power. Get the roof of the house look like 20 is the point. Bang! I get the answer. Okay, I wait for you. Dollar, money. What is my future value? See, I make a decision to create or to make this investment like that. We have two possibilities. The left possibility and the right possibility. Come on. Calculator. You don't know how to use a calculator. You have no calculator. Why no? Okay, you don't pass this class without calculator. I told you. Okay, who said that? Sean? Okay, good. Okay, the answer is, you say 37, say $36,874. Bueno, I trunced. Rounded. Pero rounded to 47, no? 47 because actually my calculator give me 36,874.39 892. You know, we are talking about currency, money. Therefore, we're using only 2 decimal places. But the last is greater than or equal 5. So you increase in plus 1, is 40. So you basically, my goal is compare this money and this money, and using my common sense, it's obvious that this is the best option. Any question? Any question? Confusing? Weird? Completely crazy? Completely nice? Understandable? Come on, opinion! Come on, typing in the chat. What do you think? Understandable. Okay. Well, similar problem. Similar problem we can see in the test. We have 2 options. And you try to determine what is the best option. In this case, it's obvious using the common sense that we get the option that contain the graded future value, no? And suppose case present value. So in order to get the best option, you take the cheaper present value. But it's okay. Okay. The 5 and 6 question. The 5 and 6 question, 5 and 6, is similar. It's another classical question in the test. It's do the graph again, but in this case, no exponential. No. Logarithmic. For example, the first function is f of x is equal log 2 of x. And the second is f of x equal log 1/2 x. The difference is clear. The difference is the base is similar. It's greater than 1. The base is 2. Look, the base here is 2. And the base here is 1/2. And when the base is greater than 1, the logarithmic function is increasing. When the base is less than 1, the logarithmic function is decreasing. Look like that. But okay. In detail now. Let's do it in details. The graph of this. And just in case, after we checking in decimals. Okay. So we're using the classical point. And the logarithm function, the classical or universal point is 1,0. It's completely opposite to the exponential. Remember, the exponential is 0,1. But now remember the relationship between exponential and logarithm. The logarithm is the inverse function of the exponential. Therefore, you interchange x and y. So you plot that point. Bam, 1,0. Bam, 1,0. Entonces you're using arbitrary value? No. You're using the logical value. What is the logical value? Logical value is the number que is power of 2, because the base is 2 or 1/2, no? Suppose logarithm base, I know, base 2 of 2 is 1. That represents the point 2,1. Because this is the x value and this is the y value, no? And you plot that 2 here and 1. This is my second point, 2,1. That was 1,0. We can do another. Yeah. But the classical illustrate very well both branch of the curve is logarithm base 2 of 1/2. Because 1/2 is the reciprocal of 2. Therefore, the answer we expect is -1. Guys, see, you are not clear that the answer is -1. We can compute it by hand, or we can put in a calculator. Remember, in the calculator, we working always with the standard logarithm, no base 2. We have no this logarithm in the calculator. Okay. So you have a doubt of this. I want to explain right now. Okay, so the point would be 1/2, -1. Okay, 1/2 is here, is the half of this segment, and -1 is down here, -1, the same distance. And the point is here. This point is the point 1/2, -1, and our curve look like that, connecting by the line. I know exactly what is the shape for the logarithmic function. And don't forget, it's super important piece of information, any graph of the logarithmic function contain vertical asymptote, at x equals 0. Okay, and the other thing we are doing exactly the same. Always a universal vertical asymptote at x equals 0. Any question on the first one? Do you understand? Okay, we can use another point. You can, if you want. For example, another important or interesting point is logarithm base 2 of 4, que es obvio que es 2, no? And the point is 4,2. Suppose que this 4 is 4,2, and so on. But this is the most important point. Always you see that always in exponential and logarithm we use 0, 1, and -1. This is the classical point. 0, and this in exponential we use the x value, and the logarithm we use the y value. Look. And this point is y1, and this point is the y0, and this point is y equal -1. Exactly the same we are doing when the base is 1/2. The only thing you need to be aware is when the base is less than 1, my logarithmic function is decreasing. Passing through the universal point is 1,0. But we compare, for example, logarithm base 1/2 of 1/2. It's obvious que es 1. When the number inside the argument of the logarithm is coincident, it's exactly the same, the base, it's obvious que es 1. We plot that point. By the way, it's the point 1/2, 1. Well, 1/2 is located here. 1/2, comma 1. I plot that point. This point is the point, 1/2, comma 1. Another important logarithm is logarithm base 1/2 of 2, que es -1. Because 2 is the reciprocal of 1/2, no? And the point would be 2, comma -1. And 2 is here, and -1 is here. Bam, 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 bam. This is my third point, 2, comma -1. And we're connecting this point, and this point by the curve. You know approximately what is the shape of this curve. Well, actually it's decreasing, and it's asymptotically, o sea, approach, pero never touch, never cast. End the story. End the story. This is the graph by hand, using the important point. Que normally is 0, universal, 1, and -1. Okay, no problem. Do you want to do in using decimals? Yes or no? Of course, yes or no? Well, any question, any doubt, anything that you don't understand very well. In the test, I don't know what is the base. Si es 3, si es 4, si es 1/4, si es 1/3, but the procedure is the same, right? Good or no? Okay, let's do it in decimal by curiosity. Okay. Let me go to decimals. Yes, please. Okay. Yes, please. Yes, please. Yes, please. Yes, please. Okay, I have decimals. Let me share screen. To decimals. In this moment, I suppose, can you see decimal, right? What is the number of the question? Is the question number 5 and 6. Question 5. Question capital letter. Question 5. Okay, I put it here. I drag. Okay, entonces in this case I put a y equal. Okay, entonces I try to find the here in the functions. Okay, miscellaneous part. You try to find any logarithm. This is a standard, ln, log, but this is arbitrary, non-standard. Que unfortunately some calculators have, pero no all calculators have. Pero bueno, Desmo is fantastic, and you put it here, and you put the base 2 of x. Bam! Here we have the graph. Okay, to make sure that everything is okay, I plot the most important point. The first point is the point 1,0. Bam! 1,0 belong to the hour curve. One more point below to the hour curve. Well, the point 2,1, no? 2,1. Bam! And the point, open parenthesis, 1/2, comma, -1, que es el recíproco, -1. Bam. And don't forget, please, the famous vertical asymptote that any logarithmic curve have. Okay, it is the x equals 0, equals 0. Okay, but black color, dotted line, like every asymptote. And this is my beautiful graph. I am ready to share. Question 5. Any question? Are you clear? Are you confusing? Okay, let's do in question 6 using decimals. Clear. Okay, now let's move on to question 6. Question 6 is similar, very, very similar, except Let me press enter. Create. No, coño. Create here a folder. A folder que is called question 6. I put in the first place. No, delete that. Okay, super. I put a y equal. Okay, and the keyboard for Desmos is more comfortable. Put y equal, and the functions, we go to the variable. Variable no, it's a miscellaneous. You select the non-standard logarithm. The base is 1/2. In this case, it's a little bit complicated to type in 1/2 here, but I recommend you put 0.5. 0.5. It's much better. Of x. Bang! You see it decreasing. Okay, now you're typing the famous point. 1,0 universal point. Bang! Recolor. Another point is separated by comma, parentheses. Carajo. Parentheses. 1/2, 1 or 0.5, whatever you want, 0.5, 1. Good, that's another point. And the other point is 2, -1. Separated by comma, 2, -1. -1. Okay, don't forget the vertical axis is at x equals 0. I change the color and the style like a dotted line. Final answer. In this case, I'm using purple color. Well, it's okay. Because the color is black. Any question, guy? Wow, we are the best in Miami-Dade College. Yes or no? We have no problem. How do you feel? How do you feel in the curves? Logarithm or exponential? Do you need an extra example or no? 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 No. Who said no? I am ready for destroy any graph. Switching to the switching. Whiteboard. Okay, let's move on to the another topic. Another topic, for example, is important. Now we convert in the question 7. We convert several statements from logarithmic statement to exponential. So, for example, give me A, B, C. A, B, and C. And we have log base 2 of 132 is equal -5. You don't need to prove that this is true. Actually, you suppose it's true. Somebody do the computation of this, and this is fantastic. However, the challenge is not like that. It's convert to exponential. So you identification with the base, with the exponent, with the result, and you change. This is logarithmic statements, and you change to exponential. Let's do it. It's convert to exponential. Convert to exponential. Convert to exponential. There are many ways to understand that. However, in my opinion, the best way is you identification who is the base first. The base is this small number here, right? Guess 2 in the first example, no? And you put a big 2 because now it's the base. In our new way to see the problem is exponential statement. And the exponent is always the result of the logarithm, because this is the intention for the logarithm. Logarithm say, what is the exponent necessary to raise the base 2 in order to get the number inside the argument gets 1 over 32. Okay, and this statement is equivalent 100% to this. What is the only difference? This is logarithm statement, log, and this is exponential. You apply this elementary procedure, and you will be able to find the rest. This 3 is the base, the exponent is -5, is equal 1 over 243. And here is 2, the exponent is -10, is equal 1 over 1024. And we convert from logarithm to exponential. Any question? Good or not good? Yes or no? Come on, I need to get feedback. It's important for me. Good, good. Sabrina dice good. Entonces Sabrina and Ruth is the only student que talk to me. Okay, Elizabeth dice good. Elizabeth de Armas. And who more is good? How do you feel? For example, Marta Chivas, no? Marta. Where is Marta? Marta, you're there. Marta Chivas. Marta Chivas, are you there? You are aware or you are distraction? Marta Chivas. Yaneli Garcia. Yulisa. Wow, unbelievable. Okay, now let's do in opposite direction. In opposite direction is I give you the exponential and we convert to the logarithmic form. Now the question 8 is convert. So we have ABC again, ABC. But we have logarithmic statement, exponential statement. Sorry. This is my first. 2 to the -5th power is equal 1 over 32. And 4 to the -3 is equal 1 over 64. And you change now to logarithmic, to log. No estándar, sino the same logarithm que corresponde a the base. The same logarithm que corresponde to the base. Okay. Let's do it. The first one. You put a famous word log. And you identify what's the base. The base is obvious in the first string. You put a small tree here. You open the parenthesis. Inside the parenthesis, we have a number that represents the argument for the logarithm, but the answer I know is always the exponent, and the exponent is -4. This is the exponent, and 1 over 84. Okay, this is the same equivalent. This in algebra, this and this are equivalent, but a different way. This is exponential way. This is logarithmic way. It's important in this chapter that you will be able to understand very well. It's 84. It's 84. No, it's 81. It's 81. It's obvious it's 81 because look. 3 to the -4 is equal 1 over 3 to the 4th power, and 3 to the 4th power is 3 times 3 times 3 times 3, and 3 times 3 is 9, and 9 times 9 is 81. It's 81, no 84. I don't know si in the test I put 81. 81, no? In the copy I put 84 or I put 81. It's Sabrina. Okay. The second is log 84. Entonces I know. In red in the black. Stay. 81. 81. This 81 is exactly this 81. I don't know, I put 84, I am crazy. And you know, my brain is classical, can anticipate the answer. See, I know that the answer is 4, so I put 84, because I anticipate this. This is my mistake always, que my brain anticipate the answer. Entonces, logaritmo base 2, because in this example the base is 2, of the one number inside the parentheses, and the exponent is -5, and the number in the argument is 1/32. The last one is similar. Logarithm base 4, the base is 4 of the one number that I have no idea, but I know that the exponent is -3. Okay, the answer for the logarithm is all with the exponent. And the number inside the argument is 1/64. Okay, let me summarize. Look, in general, in the exponential statement, and logarithm statement. In exponential statement, we have a base, que is a number. We have the exponent, and the answer I want to call result. I call result because it's the result for the exponential statement. When you change to logarithm, and this is interchangeable, so you put the famous word log, and you put a small number here que es the base. This base is this number, pero without parentheses. I omit the parentheses. Entonces, inside the parentheses, you put something, I don't know, and the answer is the exponent. This exponent is this exponent. And the number inside the parentheses is the result of the hypothetical logarithm statement, exponential statement, sorry. Okay? And this is the formula. And this is the formula que using, you know, the common sense, you know, the common sense is you, for example, identification base, exponent, result, okay? Okay, guys, entonces everything so far. We continue review Wednesday with the next question. Please, great, okay, thank you, Ruth. The student can need the review packet, please let me know by email. I send for everyone. Thank you, Sabrina. I send for everyone. Okay. Off. Okay, I send for everyone. Okay. Okay, guys, bye. I stop recording.